Hi guys, welcome to my Math and Physics Hub. This time I'm going to cover the unfinished question I mentioned in the last video. Today I'm going to cover the second part. The second part needs the knowledge of composite functions and its graph. So let's start. Hi, this time I'm going to do the second sub-question. Before we move on, I need to introduce something like composite function because it's mentioned in our question. So I'll do something for here. Let's say fg is a composite function. The question is asking for its existence. So how does fg exist? We know that a function has a range and a domain, right? Let's say this function is over here, right? So its domain is this. It's independent variables range. So this is domain. We call it, let's say this is fx, so its domain we note as df. And this range, how about this range? This is its range from lowest point to highest. So this is range. And note as rf. For f it's like this. And for g, how about g? You know idea. So we need to know g's domain and g's range, right? But for fg, it's different. What is fg? Fg is basically f with g inside. So in this case, g is independent variable and f is its function. So whenever g is changing, then f must change accordingly. So look at this graph. Gx is something like this, right? Like this axis. And f is this axis. So in this case, g must be within f's domain, right? So that means g's range, right? G's range must be within or equal to f's domain. Then fg exists. That's why, because whenever x is changing, then g is changing accordingly. So g has a, has a range or has a space to change. So this range must be smaller or equal to f's domain, because f need this domain to have such variation. So in this question, we need to to find out rg and fd accordingly. Let's go back to the question. So our f is something like this, our g is something like this. What is our rg? We have already drawn this graph out, right? In our previous part, we know the lowest point is 2, 2. So this is the lowest point, and this is gx, right? We have already drawn it out. So for g, its domain is all the way here, so it's all the way there, right? It's all the way less or equal than 2. And all the way to negative infinity, all the way there. You can know idea the least one. So for g, dg is like this. How about rg? The range. The range is from the slowest point all the way up. You can know idea the greatest one. So it's 2 and positive infinity. This is rg. How about about f. As long as we know that we only need to know f domain, so and g's range, then it's good enough. So f's domain is, we already get it from the question, is greater than 1. So whatever greater than 1 till positive infinity. Alright, let's analyze. This df, I just draw a one-dimensional, is greater than 1, right? All the way to infinity. And RG is positive 2. It's inclusive, so I draw a black dot all the way to infinity. RG is this. DF is, so DF includes RG, right? Because it has more in the graph. So DF includes RG. Then we can comment FG exists, right? And the second part of this question, define FG and find its range. We need to find out what FG exactly is. I need more space. So we know that FG is basically f with gx inside, right? Let's do a substitution so you guys may, get it clearer. So this g, let's u be gx. So we know that x is less or greater than less or equal than 2, and this gx has a range from 2 to infinity. So where u must be greater or equal than 2, right? In this case, fg will be fu, right? By fu, you just substitute this x with u, you just change this x into u, you get this, right? You get this. And you already know that u is gx, where u equals to this gx minus 4x plus 6. So we just substitute this into it. It will be 1 minus 2 ln, and this one minus 1, right? So it's x squared minus 4x. It's minus 1 plus 6. It will be 5. So this will be a fg, and we need to find out its range. What is the range for fg? Actually, we know that x, in this case, we must use the domain of g, right? Because it's inclusive. So domain of g is as is less or equal than 2. So in this case, the whole thing's domain will be equals to the domain, the range of x in this case. So according to these, we're going to find out this RFG, right? We now need to do something to find out this range. As long as we know this one is within the logarithm. How about this long? Long's graph is basically like this, right? This is 1. It's all the way down and all the way up. but from this point 1. And we know that x is less or less or equal to 2 for this part. So for x minus 4x plus 5, we draw a we know that it's the same thing as this, as long as this a and b never changes. It's 2, right? The only thing changes this point is 2a. 2 you substitute this 2 in, it will be 1, right? The only thing is this. And we know that x is less or equal than 2, so we only need this part. That means x squared minus 4 plus 5 must be greater or equal to 1, right? So with this whole thing, we think logarithm greater or equal to 1, which means in this graph, whatever in logarithm must be greater or equal to 1, right? We just, alright, I do some further substitution. I already use u, so I use v equals to plus 5, right? So as long as x is less or equal to 2, we got v must be greater than 1 or equal to 1, right? So in this case, ln v will be greater than 0, greater or equal to 0, right? And since fu or fg equals to 1 minus 2 ln v, right? And this one must be greater or equal to 0. Well, it's quite simple. Okay, while we get the range for this, we just need to get the whole thing out. So how to do it? Let's say this fg, this thing we shift there. We shift this -1 to the left-hand side. We remain with this, right? And we do some further simplification. I divided by -2 on both sides. So ln v will be equal to -1/2, right? And fg minus 1 in this case, right? And this whole thing, -half fg minus 1 must be greater or equal to 0. So we get the thing divided by this thing. This sign must be changed because it's negative, right? So it's fg minus 1 less or equal to 0, right? Then fg must be less or equal to 1. Then we get this domain. Well, perfect. It will be less than 1, so less than 1. Don't know how small it is, so I just put -infinity. This will be the answer. Hey guys, we're done with the solution. If you have any questions to discuss with me, or you want to share some idea, you can just leave me a message or just comment under the video. Hope you guys like my video. If you like it, please subscribe my channel. See you guys in the next video.